Honors Math 2, Unit 0, review for the fall final. Unit 0 and Unit 1 were the two tests that had the lowest averages, at least in my class. So I know that Unit 0 and Unit 1 are the hardest ones, and really the reason why that they're hard is because there's so many little spots to make mistakes. Some of you sometimes don't add a negative and a positive correctly sometimes when you're doing things quickly. When there's a rule of taking two bases and do I add the exponents, do I multiply the exponents, that gets confusing. Like if I were to highlight the main idea of Unit 0 of where students make the most amount of mistakes, the most amount of mistakes happen when you combine negative exponents, multiplying two things with the same base, and even having fractions with the same base and exponents. Like if I put all those, because we don't just do one rule at a time in Honors Math 2, we will combine 3 of these. Fully expecting you know what to do with parentheses and division and multiplication and negative exponents. I could make a problem that has all 4 rules at the exact same time. And so what makes Unit 0 hard is really, do I know what to do with my rules when there's a bunch of them put together? Now if you get there, if you look at Section 5 has all 4 rules that you are expected to know. And just know that there's an order of operations that goes with this, so you will have to be able to handle that. And trust me, I will have choice A being, okay, if they make this mistake, it'll be choice A. If they make this mistake, it'll be choice C. If they make this mistake, it will be choice, and I just figure out on the final. The 3 most common mistakes are other choices, are distractors. And then there's one correct answer on there. Sometimes, if you're a person who gets easily distracted on finals, one of my recommendations is cover up the answers. I have seen some students be very successful taking a Post-it note and covering the 4 choices, working out the problem, and then checking to see if their answer matches one of the 4 choices. Because some people otherwise just look at the choices and go, oh, it has to be this one, when there are some small mistakes. So let's review real quick. A exponent represents how many factors there are. Because we have 4 to the 2nd power times 4 to the 5th power, we have 2 factors of 4 that are multiplying. This means that we have a 4 times a 4 multiplied by 5 factors of 4. A 4 times a 4 times a 4 times a 4 times a 4. So technically, this represents that we have how many factors of 4? We have 7. This is 4 to the 7th power before you do it. You can add the exponents. And so there are rules, the rules that are clearly outlined here. But instead of just memorizing rules, the reason why I started off with section 1 this way was I can go, hey, instead of just memorizing rules, why don't you know what this means? This means you have 2 factors of 4 that are multiplying. Here you have 5 factors of 4 that are multiplying. Why not know that you're multiplying the 2 factors times the 5 factors, which makes 7 total factors of 4 that are multiplying. And I try to explain it that way. That way you don't just go and try to memorize a bunch of rules. Memorizing rules is hard because what happens if you forget a rule? Coming up with what things mean are easier because then you can actually create the rule yourself just by making your own example. That's the beauty of deriving your own thoughts. When you're multiplying, we throw in this idea with variables because sometimes you're going to have to multiply your coefficients. The negative 4 will multiply the 15. The x is multiplying the x to the 4th because you're just Multiplication is done where you multiply numbers with numbers, x's with x's, and y's with y's. There's no plus signs here. There's no distributive property here. This is just a matter of multiplying numbers with numbers. How many factors of x do you have? How many factors of y do you have? But when you have exponents outside of parentheses, if you don't know what the rule is, then write out what it means. Like, I could go into section 5, which have all the rules that talk about, oh, when you have something outside the parentheses, you can just multiply your exponents. But if you don't know that rule, then sometimes what it's easier to do is, well, I know 5 groups of 3x squared y, and there's another 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 3x squared. If you need to do that, then do that. Sometimes that's just easier. And then what happens is the mistakes that I saw on the test in Unit 0, some students didn't do 3 to the 5th. You know what they did? They did 3 times 5. So is 15 as a coefficient going to be one of my distractors on your final? Absolutely. I know students like to do 3 times 5, 15. It's not 15. It's 3 times 3 times 3 times 3 times 3. That's a big number. That's 81 times 3, which is 243. Does that sound right? That's mental math. Mr. Problem almost wants to bring out a calculator just to figure that out, but I'm just going to pretend that it is 243. X to the 10th, y to the 5th. Because we have 5 factors of y, we have 10 factors of x. Or you can just multiply the exponents. But don't forget, this is 3 to the 5th, which made that 243 x 10 y 5th. Unit 0, let me just say this again. Now that you've seen Unit 0, you've been in my class for a whole semester, it's almost Christmas. Let me just say, Unit 0 was not hard. It was just an easy place to make mistakes. And so I'm going to suggest to you, when you get these problems, slow down. What does it mean? If you are a person who doesn't want to do it that way, then you need to be memorizing your rules and knowing your order of operations, and that will help you out a lot. There we go. We also learned, besides that, in this unit, we talked about how to go from something called exponential form into radical form and how to simplify radicals. The beauty of most of the calculators I've recommended to you, the Casios that we use in the back of the classroom, they do radical form. You could literally type in radical 20 and it will put it in radical form for you. Same with radical 63. Or if you want to know how to do it by hand, you can do that. But you would not be able to punch in m to the 3rd or n into a radical, so we have to know how to do that. When you're doing the square root of a number or a variable, you have to remember what it means. You're looking for 2 factors that can simplify inside the radical. So if you remember that m to the 3rd is m times n, m times m times m, and there's an n multiplying as well. You need 2 factors to break out of this radical. This would simplify. 5 times 5 is 25. The square root of 25 is 5. If it has a pair, you can circle it, and one of those factors can fall out or break out. If it has 2 factors of m, you can factor out an m, one of those. If there was another factor of m, you would factor out another one. And if it doesn't have 2 factors that are the same, you leave it inside. So for number 7, this one would be 5m root. There's a 2 still in there. There is an m still in there. and there's an n still in there. Simplified radical form is about breaking out as many factors as the root has. If I can break out a square or two, if it's a third root, you're looking for 3 factors that you circle, and for every group you circle, one of those breaks out. I don't think this was a main idea, but rational numbers are ones that simplify. Irrational numbers do not. Those are things that still have radical symbols. Those will always make an irrational number. There's other ways to say what an irrational number, but it's a number that never repeats itself or goes on forever. That was brought up here because some radicals simplify and some don't. That's irrational. How do we multiply a couple radicals? The easiest thing I explained a long time ago was insides multiply insides. That means things inside a radical multiply things inside a radical. The 12 will multiply the 30. Outsides multiply outsides. The 3 will multiply the 4 because those are in front of your radicals. I also recommended a long time ago, let me just do a quick reminder, that if you're multiplying insides with insides, don't worry about the product yet. For example, let me just look at number 9 right here. Outside times outside is 10. M times nothing is just M. And then we have this inside times inside. Instead of doing 48 times 27, instead of making that bigger, way back then I said, try making it smaller first. Break it apart. It makes it easier if you just break this into like 3, not 3, how about 6 times 8? And 2 times 3. That's a 2 times 4 and a 2 times 2. There we go. Once you split it apart into smaller parts, you don't really need to use it. I don't use the 48 anymore. I don't use the 6 because I broke that down into a 2 times 3. And I don't use the 8 because I broke that to 2 times 4 and so on. I don't need to do 48 times 27 because I know that's 3 times 9 and 3 times 3. And so now I can just look for the 48 times 27. Well, don't make it bigger. You're just going to split it apart anyways. Looking for squares of numbers. Before I forget, I'm going to put the m times m and then the n times n times n times n times n times n because there's 6 of them inside. And I look for things that have pairs. 1, 2, 2 pops out, cross them off. 1, 2, 2 pops out, cross it off. 1, 2, 3 pops out, cross it off. Another 3 and another 3 pops out, cross it off. Now let me look. Anything left? Does all that simplify? Do all the numbers end up popping out? Yes, that's what we're looking for. Do all the m's pop out? Do all the n's pop out? Absolutely. We have another m over here. We have a 1, 2, 3 n's that will pop out there. On an example like this, you have 2 times 2 is 4. 4 times 9 is 36. 36 times 10 is 360. M times m is m squared. N to the third, and nothing is left inside the radical, making it rational, by the way. You could only add radicals that are the same radical or the same radicand, I should say, in the same index. So what that means is, if I have 2 root 7 plus root 63, we cannot add those together. You have to think of these like, like terms. 2x plus, this is in a x, this is a root 63. 2 radical 7, I can only add radical 7s to other radical 7s. So there will be times where you might have to break things down, simplify them, so that you can then put the 2 radical 7 plus the 3 radical 7. Then you can put them together. What is 2 radical 7 plus 3 radical 7? It comes out to 5 radical 7. You might have to do that with fourth roots, and so on. You have to rationalize. Rationalizing, getting things out of the denominator. This isn't a main idea, but your answers from this section will be rationalized. Meaning if there's a square root over a denominator, we will multiply and rationalize denominators. If you've forgotten, you do not need to always multiply by how many things you have. I always told you the easiest way to think about this is what is it made up of, and if you need 3 factors to break out, we're going to multiply by the number 1 to make this rationalized. The way I'm going to cheat is I need one additional factor of 3, a third root of 7, because I can only multiply third roots with other third roots, and that would make 3 factors of 7. You can't just multiply by the bottom by that, you have to multiply the top. This creates 3 of those guys. A 7 can pop out. The top would be the third root of 7. So sometimes the easiest way to find what you need is to break it apart first and then look for how many additional factors. Back when we took this test, some of you forgot that you're multiplying a third root by a third root. Don't forget the third roots there. And that, of course, goes to the top and the bottom of the radical. All our rules. And lastly, we had to know how to switch from exponential form into radical form, because that's where a variety of problems came from. If you have an exponential form, the bottom number is your root. The top number is your power. Easiest way to remember that is where do flowers get their power from? They get their power up above the sun, and the roots grow in the dirt in the bottom. So it's easy. Roots, power, power, roots. And the 3 can be here, or it could even be outside the radical. It doesn't have to be underneath, by the way. Exponential form, radical form, and switching back and forth is something that we did. Oh, look at those square roots. Oh, I love that picture. It just brings me some happiness and joy. Like I said, I love these kind of questions. They were in that unit. I want to say there's going to be at least something like this on your final, because what this does is this really tests, do you know radical form? Do you know exponential form? Do you know your rules of exponents? For example, this is 12 to the 3/5 power. This is times 12 to the 8/5 power. And if this says 12 to the x/5, what we're trying to see is, do you know how to go from exponential or radical form into exponential form? And then what do I do with my exponents? When you have the same base, you add them. 3/5 plus 8/5 is 11/5. And then if you look at this, right at this point, you should see 12 to the 11/5 is equal to 12 to the x over 5. You can tell that x has to be equal to 11 on that problem. It combines all the rules together. Love problems or examples that are like that. And there's nothing different about 6B than there was on 6A. So that's a huge review. Unit 0 has a lot of things in there. Let's end right there.